All right, so our invader spotlight for this week is white nose syndrome, Geomyces destructans. So, white nose syndrome is a fungal pathogen. It is native to Europe, evolved along with uh, bats in Europe. So, sort of a evolutionary arms race in terms of the fungus becoming more virulent and the bats developing resistance to that fungus over time. There is a relative of white nose syndrome, so another fungal pathogen that is native to North America that also affects bats in North America, but it's the European strain of it that has caused widespread destruction and loss of populations of bats. So, as of a few years ago, this syndrome, the fungus was responsible for the death of 5.7 million bats. And that's not just the little brown bat. Little brown bat was the most common species that it affects, but there are 9 species of the genus Myotis, which have been affected by white nose syndrome. So this map is the distribution of white nose syndrome as of 2009. It was first identified at the end of the winter of 2006 in outside of some caves in New York. We're not sure exactly how it got over here, but it was probably introduced accidentally on some dirty equipment by recreational cavers who had come over relatively recently from Europe. So that's the map from 2009. By 2012, it had spread out of New England, so widespread in New England, out into Canada and into the Midwest. By 2018 and more recently, it had spread further out into the Midwest, and there have recently been some detections in the Pacific Northwest bats as well. So, what actually happens when this fungus infects a little brown bat or other bats of the genus Myotis? So, this is a graph from a paper by Warnecki from 2012, where they were trying to figure out what is it actually that is killing all of these bats. And so they had a number of bat individuals, and these are time series. So the x-axis goes from day zero, when the bats, some of these individuals were initially infected, to 90 days after that initial infection. And what you're seeing on the y-axis is skin temperature of those bats. So this is during hibernation. So going from December to February. So when you're hibernating, you as a bat, you want your temperature to stay cold, very cold. Anytime your temperature spikes, so anytime you see one of these little spikes, that is basically the bat waking up. The term for that are bat arousals. And anytime you as a bat wake up, that is energetically costly. So in the control, you can see that it is fairly normal for a bat to wake up a few times from hibernation, go get a drink of water, go back to hibernating. So 5 times, something like that, might be a normal amount that a bat would arouse from hibernation during a 3-month winter season. The ones at the top, so remember I said that there's a North American strain of white nose syndrome, that definitely makes them sick, right? So it makes them arouse more often from hibernation. The European strain, which is the one in the middle in B, that one is even worse than the North American strain of white nose syndrome. So you can see that towards the end of the winter, that bat is waking up every few days rather than once or twice a month. And because of the energy that takes, essentially what happens is the bat starves to death. It loses, it cannot maintain its winter fat, its winter resources through to the spring. So here's another example of that. This is over a time period going from, again, December to February, early winter to late winter. You can see the control one in the white bars, not waking up all that much, waking up sometimes, but not too often. The North American white nose syndrome strain, waking up a few times, and especially towards the late winter. European white nose syndrome, that one that's outlined in red, waking up much more than the North American variety. And the reason that you don't even see a bar in that late winter is because all of those bats died. So couldn't wake up anymore because the virus had, or sorry, the fungus had killed them at that point. So this is an example in invasion ecology of something that we call species being naive to a novel pest or pathogen. So in Europe, European bats and European white nose syndrome have evolved in parallel. So white nose syndrome gains an advantage, the bats evolve to not be as susceptible to it over time. Same thing was happening in parallel in North America, North American bats evolving to withstand white nose syndrome evolving to spread through the bats more effectively. And because those two geographies were fully separated, they had different evolutionary pathways. And as it ended up, the European variety of white nose syndrome is more virulent, causes the bats to arouse more often than the North American variety. European bats, they're okay with that because they've evolved resistance to that high level of white nose syndrome virulence. North American bats, not resistant to European white nose syndrome. So an example again of species naivety, and a really sad example of it with the loss of our bat communities.